Hello, everyone. And welcome to the next edition of our SPM Summit online recharge. Today, we have a really great speaker, Rasmus Hauch from 2021 AI. And the topic will be also about artificial intelligence and its application for product management and product managers. So let me briefly introduce the format of our event today. So we will start. So we will have a presentation from Rasmus for 25 to 30 minutes, something like that. And please be aware that this session will be recorded, and we will make this video available on our YouTube channel. So we are now working on creating our YouTube channel, and so it would be really great to have this video on this channel. And so if you have any questions, please type these questions in a chat here in Zoom, and I will accumulate them and ask Rasmus after his presentation. Or please leave this question to yourself and join us for the discussion with the speaker after. So just raise your hand and ask any questions you have. I believe that it would be difficult for you to ask a question that will be challenging for Rasmus to answer. So because I guess he's the person who knows a lot about IE from both managerial perspective and technical perspective. So any question will be warmly welcome. And just short information. So this online event is a part of the preparation for our SPM Summit that will be held in March 2022 in Frankfurt, but it will be hybrid event, so you can participate physically or online. Participation will be also available, and we still have a call for contribution open. So if you have something to tell, if you want to be present there, the speaker, please submit your contribution. We will evaluate you, and hopefully we will invite you to join us as speakers. And also, please know that we organize, so that the organizer of this event is International Software Product Management Association. So feel free to join us. We have a lot to share with you, and we have great trainings offered by our board members and fellow members. And so feel free to join us and go to espma.org website for that. So it is 3:05 in Helsinki, and and I guess it's time to start our online event. And so please, Rasmus, the virtual floor, the screen is now yours. So I'm stopping sharing my screen, and welcome, Rasmus.
Thank you very much, Andrea. So let's kick it off.
Rasmus, we cannot hear you. Please turn on the microphone.
Oh, sorry. Now I can hear. Can you hear me now?
Yes.
Good. Okay. Can you? Yes. Okay. So thank you very much to you, Andre, for this presentation today. And thank you to AIbased for having me presenting today. So it's a small crowd. So I think in that sense, I think you should just if you have any questions throughout the introduction, I don't mind if you just if we do a short question answering while we go through it, but we can also take it in the end and then hold on to your questions when we go through it. So basically what I'm going to go through today is also that doing an introduction a little bit to what I am doing and the company, and then we will quickly dive into what is AI, what is machine learning, which is a question a lot of people are asking. I don't have a fantastic answer to that, but I'll explain to you what it means, and then we'll go into the different types of AI ML, and then finally look at the different possibilities. All of this with a product manager's sort of approach to things. And then finally, sort of what is the role of the software product manager inside of the AI project? What is the kind of stakeholders that you need to take care of and manage? And then finally, we'll go into the 10 pitfalls of AI product management, which I think you might find interesting, with some follow-up advices on that. So I hope that fits the agenda. And I hope that we can make it through the presentation, so we have a lot of time to do questions and stuff like that. So a little bit about me. I have around 25 years in IT architecture data. I've worked also with Antti, which is also on the call here today. Thank you for letting me join also. So working with data, obviously from the beginning, and standardization on AI governance. And also within the ISO and the Sense Elect organizations, and then also having this management sort of focus. So what we do in 2021.ai is that we are working with companies to develop and deploy and operate AI models in production. So that's sort of the general value that we are trying to bring to the customers, and we do that by offering a technology platform, doing scalability, doing it in a cost-effective way, making sure that these models are retrained, and that these models are sort of managed in various ways, and then finally offering also the risk and compliance angle to these AI models and these machine learning models, because what we're seeing in the marketplace is that to an increasing extent, there's a lot of work to be done in terms of the risk and compliance within AI going forward. But enough about that. Let's move back to what is actually what is we're talking about, and basically what we're talking about is what is the difference between a traditional piece of software and then a machine learning model. And basically, if you look at it, you can say an expert model is basically just a series of if-then-else statements. If you look at it from a perspective of saying, I want to figure out what is the price of my house, I could say, well, is it a good neighborhood? And if I say yes to that question, then does it have a garden? And if I say yes to that question also, it's probably expensive. But if it's not a good neighborhood, if it's an old house, then probably then probably the house is actually quite cheap. But it's also building a software system out of if-then-else statements becomes also quite intensive, and you need to have a lot of knowledge around the area that you're actually working in, versus machine learning models, where you can say that the input variables are actually given, and then you basically feed it through a model, a network of neurons, can you say, in the sense of neural networks, and then based on that you actually get a price. And the advantage here is that one, you don't necessarily need that much expertise within a specific area to build a model that can predict this price. So there's there's very little sort of expert knowledge involved in building these kinds of models. And the other thing is that it is able to act on previously unseen data. So if you have a house which has a medium good neighborhood and has a small garden and is medium age, then it's still able to give a price that comes out on the other end and being more correct than you could have maybe done as building an expert system. So all of that is based around the fact that it needs to have data initially. Whereas with the expert model, you don't need to have data up front, you just need a lot of knowledge. Whereas with the machine learning model, you need to have data in order to begin your model development journey. And that's a very different approach from if you look at it from a traditional product management perspective. So it all starts with the data in typically, and it's all about pattern recognition. So basically, diving a little bit more into that in terms of the development journey, you can say again in the classical software development, you have some input, you have some code, and out comes a result. Whereas in the machine learning development area, you provide the input, the input data, and then you also provide the resulting data, right? And then out of that comes a program, and that's a very different approach from the traditional ones. If you look at that again for the housing price situation, you can say again in the classical software development world, you would input the housing data, you would input some expert knowledge, and out would comes a price on the other hand. Whereas with the machine learning development, you input the house data, you input the result of it, right? The actual prices as seen in the marketplace, and then from that comes the actual model that you can then reuse again and again and run that also on previously unseen data. And this is where things are very different from a traditional software development project. So going a little bit into what kind of types of machine learning and AI there is out there, you can say that if we start with the basic machine learning, there's a whole domain of let's call it classic machine learning, and the first class here is the unsupervised classes of machine learning, where we're talking about unsupervised learning, which is basically that you don't necessarily set a target function, you just identify some clusterings and some different areas of a multi-dimensional data cloud, and then you say, well, are there any distinct characteristics around this? And then you can use that to build some models. You can use these kinds of models are typically used for predicting larger classes of data sets in a sort of a batch approach. And then you have the more classical supervised machine learning, which is based on the fact that you as with the house prices here, you have some input data for the house price. Sorry, for the parameters of the house. Is it old? Is it new? Does it have a garden? And all these kinds of data. And then there's also a price, which is what we're trying to predict for previously unseen data. And this is a typical supervised machine learning area, and there's some subsections here. Linear regression, which is a very sort of simple or pretty simple statistical model. There's a traditional classification, but then there's also some methods which lies, sort of in a boundary between classical statistical methods and then deep learning as well, which is some of these ones, random forest, XGBoost, and so on. And on the other side here, you have stuff like reinforcement learning, which is basically where you're trying to build some learning around, so that the models themselves can evolve within some boundary level conditions. And then finally, you have what you might see somewhere in the news is the neural networks, which also has a lot of different areas. There's both the networks for identification of objects in images, of sounds in audio, and obviously looking at larger quantities of text and being able to classify it or stuff like that. So regarding the possibilities, you can say the possibilities are obviously endless. It's typically around recommendations, predictions, forecasting, classification, recognition of something, scoring of something, detection of something, and scanning, and these are typically done on data like structured data, which is like a table in a database. Could be unstructured data as a large quantity of text, or it could be time series data, like you see we're in a factory where all these machines are generating different kind of time series data related to a specific series of time. And then you have the audio data, you have the images, and then you have the videos, which all of them has each of their own areas within data science and within machine learning and AI that is itself very interesting. And obviously you can also do combinations. So if we imagine the same scenario as with the house prices before, but then you add images of the house inside, and then you are able to compare parameters from the house with actual images from within the house, and based on both the images and the parameters of the house, you can then get an even better price a prediction for that particular house. So all of this was a little bit around machine learning and AI and how that fits together, you can say. But the primary problem for a product manager in this situation is where to start, right? Especially if you're coming from a small and medium-sized organization where you might not even have a product yet. You might not have any users. And then if you don't really have a product, if you don't really have users, then how can you do machine learning? Because the problem is that the more users you have on your product, the more data you can then potentially get. And when you have more data, then you can also improve your product. So this is sort of both a positive circle, and it's also a bad circle, right? Because if you are in the beginning of any kind of product development journey, then it's very difficult for you to build a good AI product if you don't have any users, if you don't have any data. So that's very difficult. So one of my recommendations, and we'll get to that later, is that you should also be not be afraid to go out in the market and find data, either some public data, or it could be also to buy data from various companies to improve your product over time. So that's a very important aspect, is to be aware that if you don't have any data, it is quite difficult to build a machine learning product. So looking at this from a product manager's perspective, then you can say you have I call them the 4 pillars, and obviously that starts with the data. It starts with the model, and these areas are typically seen from a data science perspective. It's around getting the data, doing the quality checks and the testing of the data, cleaning the data, making sure the data is ready for training, then training the model, then testing the model, and then finally deploying and operating this model in production. So all of this is within the blue circle down there, which is typically stuff that the data scientists are doing. But when the model is put into operations, then typically it's within the orange circle, within IT, which is typically like IT infrastructure kind of things. Because the problem with AI models, both when they're being trained and also when they're being operated, when they're being run in production, they can require quite a bit of infrastructure. So some of these models, if you take an image recognition model, for example, that typically needs to run on a GPU machine, so like a machine that has a graphics processor unit inside of it, and that's quite expensive to run in a cloud environment. So therefore, these things needs to be managed. Or if you run it on your own computer, then you need to make sure you have the necessary requirements for that. So those are 2 very important aspects when you're working as an AI product manager. But obviously, the most important one is that you have business value. So because, and I'll get more into that later, that you should be super focused on creating business value and not just focus on the hot and sexy AI models, but rather on what is creating value for this company right now in this instance. So that's important one. And then the gray circle there, governance, that's also something to be aware of, and a new emerging area, can you say, which is about looking at what is the potential risk for the company of implementing and deploying these AI models, both looking at it from a perspective of using of personal data. And what are this personal data? What is that being used for inside of the models, and how are these models being developed, and how are these models being deployed and operated, especially when it comes to things like bias and bias management and bias mitigation, but also in terms of cybersecurity and potential risk of being compromised. So there's a lot of areas there. And then finally, there's the area within governance around the legal aspects and making sure that you're compliant with the legal perspectives of this. And I'll get back to that also. So basically, now let's dive in a little bit into the pitfalls, right? So imagine now that you are an AI product manager and you're starting the project. So the typical sentence you will start to say to the business side is that AI can do anything, and that's not entirely accurate. You can say that and I think this is a good depiction of that. It's a big mess of data, and maybe if you stir the pile a little bit, then sometimes some good stuff might come out of it. But in many cases, it's just the crap that comes in and crap that comes out the other side. So my advice is that start by writing down some hypotheses, some statements that says, can we try to do this in this domain, and then try to prove them using some identified data sources and doing some initial data exploration. So I really encourage you to write down some business opportunities and sort of annotating them with individual complexity, with some business value. Do we have the data? What kind of source quality is there, or data quality? What kind of customers would be interested in this, and so on. So start by doing that, and then start by doing a lot of them, because then if some of them fail along the way, then you have something to sort of come back to if things are not working out as they should. So that was pitfall number one. Pitfall number two is AI is always the answer, which again is not really true. So this guy here, Abraham Walsh, so he was actually living in New York during the Second World War, and he was sitting in a team called the Statistical Research Group, and they were doing research on bomber planes coming back from the Second World War, and they were looking at bullet holes within the individual planes and saying, because they wanted to do build additional armor on the actual planes, and then they looked at these holes, and then they said, yeah, that looks great. Where all the bullet holes, where the bullet holes are, let's build some armor there, because that's clearly where the planes are being hit. And and then Abraham, actually, he was a smart guy in that team, and he come out and he said, guys, that's not true. The reason why you don't see any bullet holes in the cockpit and around the fuel tanks is because these planes didn't make it home. So that's food for thought, that you should always worry about. Maybe I have some data, but maybe you need to look where there is no data today, and then see if you can get that data somehow. And also be sure to have some technical understanding of the area that you're working in terms of AI and ML. So if you have a lot of use cases surrounding NLP, natural language processing, be sure to look into that, and so on and so forth. The third pitfall is data makes a great AI. That's not true. You can have a lot of different data. You can have the fantastic pie chart like this, and that doesn't mean you have to build an AI machine learning solution on top. And also, just because you have the data does not mean that you have the right data. So make sure you have the right data and high quality data that is actually usable for building these models, especially in terms of the predictions that you want to make. And that's the thing that a lot of people don't realize, is that you might have a lot of data, but you need to annotate this data and have the right labels on it in order to be able to use it for a machine learning model. And don't be afraid to go out and buy it. Don't be afraid to build synthetic data if you're trying to do something which is like, where you want to have some specific behavior out of it. As long and realize also that data is really the frame around your AI painting. So I think that's an important point. The next pitfall is actually that complex models generate most business value, and I think there's a little bit of truth in that. As a business, if you look at it from a business perspective, really focusing on AI, can make sense, but when you start as a product manager developing your first AI product, then I think it's very important to focus not on the very complex models, because then what will happen is that you will eventually crash and burn. So what you need to do is that you need to think about, how can we minimize the risk for a particular product. And that's typically, building very simple models, even just building, the expert rule system that I showed in the beginning, like a lot of the if and else statements, just to get something and to get started on something, rather than building a huge and complex model where the risk of failure is high and you have a lot of, high risk of running out of money very early on. So please be aware of that one as well. Number 5 is that AI and machine learning products are quick. They're not. And in fact, building the actual model is a very small part of it. If you just look at the data science part of it, there's a lot of areas around data collection, around data testing, verification, and finally operating these models. That does require a lot of time and a lot of effort for the data teams and the IT teams to do this. So my advice is to look at platforms, look at systems out there that can support, the AI machine learning development journey that you're on, and the products that you're working on, and make sure that you can use these to scale sort of your product and govern them as well. Pitfall number 6: no testing is required. Not true. In fact, I think, in terms of testing, for AI machine learning models, there's a lot more testing than there is. It's all the software testing part, but then there's also the data and the model part, which also needs to be trained. So a lot of testing is required, and the testing is not just in development as it is with normal software products. It's also after you have deployed and are operating these models, it also needs to be tested continuously. So a very important point. Test, both in development and test when you are in production and after running in production. And there's a lot of areas around data science testing, a lot of new concepts. I'm not going to go through all of them now, but just say that there's a lot of things to be aware of there. Number 7: once projects are done, they don't require maintenance. Not true. So if you have, a model that's been running for some time, then what actually happens in real life is that they have a tendency to get dumber. So models get dumber over time, and models can even be very damaging to the company if they're not properly retrained. So my example of that being a churn model that's running in a financial organization and has been so for the last 5 years, and nobody really looked into it, and it turns out that it's actually doing a lot of things in the company that is actually more damaging than it should be, or more damaging than doing good stuff in the company. So always find platforms that can automate the retraining, the recalculation of bias and accuracy. So make sure that you're still at the level where you want to be in terms of every time new data comes in, because almost all models, I mean, there's a few exceptions, but almost all models, they require retraining at some point. Doesn't matter if it's image recognition, video recognition, if it's structured data models like forecasting models and so on. The data surrounding or the environment surrounding these models changes over time. So be aware of that and also think that into the project and the project plan as such. Number 8: trust doesn't matter. Not true. Trust has a lot of or is a very important aspect for product management working with AI. Think about things like transparency, fairness, accountability, privacy, obviously, explainability, explaining the results of these models to the customers and users that are going to use these products, and also explainability even internally in the company, right? So when launching these products, how what kind of transparency does these models have, and so on. This is a very important aspect. You are the front gatekeeper for bias, for fairness, for explainability, and privacy issues when it comes to this product. Not anybody else, just you. So be aware. Finally, rules and regulations is not important for AI. Not true. In fact, there's a lot of different regulations out there in terms that are targeting more or less, or in some ways, or other ways are targeting AI models and also processes. And I think the good example is Fodino, which is an Italian food delivery company that was just here the 10th of June this year, was fined 2.6 million euros. They have around 19,000 riders, which is like bringing food around to users out there. And they have two systems. They have sort of a scoring system that scores each of the riders in terms of how good they are to bring out the food. And they actually got this fine because the algorithms and the models they built, they were not transparent. They had no fairness involved. They had no way for the riders to be able to communicate with the company in terms of asking questions, stuff like that. So there's no transparency. There was no fairness metrics, and there was no accuracy also around the models. They were probably really great at delivering food, but it was not really benefiting the people that were working, delivering this food. Right? So that's an excellent case. I'm just mentioning this one because there is like 1,000 cases out there, which is much worse than this one actually. But I think this one is a very recent one, and the verdicts and the way they got defined was very, very, very clearly defined in the fine they got. So make sure that you know what kind of industry you're in, and the model type that you're working with, the kind of data that you're working with, and then look at the legal perspective and make sure that you have everything covered before you go out and deploy and operate AI products out there. Because I think if you don't do that, you might get on the front page on a newspaper somewhere, or get a fine, or both. So make sure you look into that before you start releasing these products. And finally, always elements around cybersecurity, data anonymization. There's a lot of security and regulatory things you need to look at when it comes to AI models that are specific to that area, not just on software in general. Finally, AI pitfall number 10, all data scientists are gods. Not true, although I think this is a god. So basically, if you look at data scientists as a whole, their skills are very different. And they have, first of all, there's different areas of data science, right? There's image recognition, there's NLP, there's structured data, there is, recommender systems, classification systems, and so on and so forth. So there's a whole world of different, mathematical areas and the machine learning areas that require different skills. And then on top of that, there's also a lot of different areas within data science, kind of different roles within data science that you can do. For example, data engineers are working more on the data ingest side and sort of processing and making sure that the data is ready for being trained. And the data analysts are sort of making some initial analysis and maybe some initial dashboards and so on. And you have model deployment, you have data architects, analytics managers, and so on and so forth. So there's a lot of different roles. And also realize that these kinds of projects are not just around data and models. It is a team effort. It's also business. It's also IT infrastructure people. It's also UX UI people that needs to be involved. So it is a team effort. and please see that as that, and not just do something together with the data scientists. I think you're done, right? And typically, if you go out and want to find data science skills, focus on people that have some open source experience, are working with Python, because this is the most used language and tools that the Python ecosystem offers in terms of developing and deploying these kinds of models. And finally, start simple and then build complexity on top of it. And also, I think it's important that you, if you look at it from a skills perspective, then if you are starting the product or product journey, then it might be easier to get sort of, you don't need you typically can get someone with relatively low skill in to do some initial work, and then once you move further and further into production journey or into releasing the product, then the skills needs to improve, which is sort of the other way around in a traditional software product where you start with the high-paid architects, and then you go and then you start the architecture, and then you work your way down in the solution that way. So it's a little bit the other way around. But yes, I think that's about it. So we have a little bit of time for questions.
Okay, so thank you very much, Rasmus, for this exciting presentation. There is a lot of hype about this artificial intelligence. So at least to me, this presentation brought some clarity. I have several questions from myself. Maybe I can start with them, and then hopefully other participants also will ask their questions. So yeah, technically my first question is not about your presentation, it's about your company. Whether your company will be renamed into 2022, i.e. next year?
That's a really good question. So so we're still a little bit unclear. I'm voting for changing the company name every year. So next year we call it 2022 and so on. But I don't know. Some are saying that we should change it to 2120. Then we have at least some years more. And yeah, I don't know where it's going. So sorry, can't answer that.
Okay. Yeah. Okay. Thank you. And I guess most serious question is, so there is a saying that data is a new oil, and we see that there's a growing concern regarding, at least like in B2C space, with data collection. So people really like not to allow companies to collect data. So do you think that this movement, especially promoted by such companies like Apple, with their new opportunities to not allow companies to collect data, will somehow affect the spread of IE and adoption of IE, or it just so it's unstoppable, the process is unstoppable, and it just something that will affect, but it will be minor effect?
Yeah, so I think since the GDPR came out and the data protection regulation, things has been actually quite surprisingly, when it came out in Europe, it kind of generated a big sort of boom on a lot of different companies, including the big tech companies that had to move their infrastructure suddenly around, and there was a lot of struggles with that. But I think after the regulation sort of was enforced in Europe, then we are seeing, or I'm seeing at least, that it's being also brought out into other countries. So the US or each of the member states, California, for example, have done their own GDPR legislation. Canada is quite upfront about it. Even China, Singapore has had it for some time. So what we're seeing is that Europe has been sort of the front runner in terms of implementing this regulation. And in terms of data, when I'm coming back to your question, I think I don't think this will stop, right? I think there's a lot of companies that is going to be very eager at collecting your data. I think that the challenge for them is going to be that they make sure that when they collect this data, that they get agreement to do so, number one. But it's not just agreement on collecting the data, but also constricting the usage of this data into certain use cases. So that's within the GDPR regulation, that if I collect your data, then I need you to sign that I'm actually will use it for this and this and this purpose. So I think we'll see more and more of those cases. I think we'll see, that companies will keep collecting data, but they will also be wary about using it for use cases other than what was intended, unless there is something, unless it's actually something they want to do from a business perspective, and then getting signatures from everybody to do that. With that said, I think there is some new and emerging technologies. One of them being homomorphic encryption, where you're able to sort of anonymize a data set and then even build a model out of it without actually exposing any kind of privacy related data, traditional anonymization. So there's a lot of other options of, not exposing privacy related data in data sets and still build models out of it. Did that answer your question?
Oh, your answer definitely makes sense. So hopefully it will follow this way. Okay. So Hans-Ben, do you have questions?
Yes, I have 2 questions. Thank you very much, Rasmus, for the most insightful presentation. One question regarding your last slide, where you talked about data scientists. That is a new role in software organizations. How do you organize this relationship between the product manager and the data scientist? Is the data scientist close or part of the product management organization? Is the data scientist part of a development organization? Is the data scientist kind of independent or under the product manager's directive? How do you organize this?
Yeah. It's a good question, right? I think, and I don't have a specific answer to that. What I'm seeing in organizations around, if you look at, if you take the data science area first, what I'm seeing is that some companies have organized so that they have a centralized data science organization, typically consulting companies that have a centralized data science organization that are only delivering data science projects to product managers, to customers around. I see other organizations where it's more chaotic, right? Where each branch of the organization has its own small data science teams that are delivering. And then I see, especially when it comes to small and medium-sized companies that are sort of launching new products and so on, I also see that there's a very tight collaboration between the product management team and the data science, and even, as you say, it's the same team more or less, right? So I'm seeing it all. I think it relies a lot on the type of organization you're involved in. If you are in a big organization, typically you're sitting as a product manager, with where you're interfacing with a data science team. And there, in that discussion and that communication, I think it's very important with some of the advices that I gave, like, keep it simple to start with, because one thing that I've experienced a lot is that I come up to a data scientist, I say, yeah, we have this data source, please build some model out of that. And they say, oh, we're going to build some crazy, fantastic big model that is super accurate. But that's not what I want as a product manager. I just want something that I can start out with. So many times we sort of come to the conclusion that, well, maybe it's better just to build a model that is not a model, but it's just exposing an interface to some other piece of software. We can get things moving, rather than spending the next 3 months building a fantastic model that we might not in the end even need, because you want to try it out with some, have some user experience, try out. I mean, that's all the traditional software development parts that you also need to make sure works, and you need all those parts working. So I see it more as a if you look at the whole AI stuff, it becomes one more wheel, can you say, in the product management job.
Okay, thank you very much. My second question is more about the product side. What is the typical AI-based model? Is it just a generic engine, or is it the engine plus let's say, a kind of generic domain-specific model?
I think, yeah, it's a good question, right? It's a really good question because, and I think the question is more on sort of the build versus buy discussions, right? And I think in that discussion, I think it's important that since if you have a company and you're already collecting this data within the company, I think there's, at least what I'm seeing in the market is that there's a lot of clients or a lot of companies out there that are saying, this is our data, we should keep these models in-house, right? So they're building their own, and they're sort of managing these models. And then back to your question, they're typically managing them in a separate environment or a separate system where the retraining of the models, where where new models can emerge from and stuff like that. So typically it's a separate environment and a separate system that are then interfacing with the product that you're then trying to develop. So in reality, one of the challenging parts is around defining the interface to these models rather than but the interface itself is one thing, like the real-time interface. Now I have, let's say it's an image recognition model, right? And so I say, well, I open my product, I get an image, and then I feed this image to the model, and then back comes a classification. Simple, right? But in fact, it's not that simple because you also have the additional aspect that you need to always feed new images into the training cycle of the model. So there's actually, a number of different processes. And one process was real-time process of the software hitting the model, and then there's another process which is retraining, where the images needs to be fed back into the system, and then going through some cycles. Some of the cycles might be that you need to annotate the images. You need to mark, if you're doing recognizing bicycles in photos, then you need to label these bicycles every time you have new photos coming in.
Well, I think the question is also related to the question of data pooling, right? Yes. I mean, does it make sense to use data from multiple sources and combine them, or is that kind of counterproductive and you really need customer-specific data for the training process?
No, I think it definitely makes sense, right? To combine. So an example, right? Building a model that can predict, and this is a real case where we build them. Where there were cameras pointing at a freeway, and then counting the cars that were passing on the street, right? Mm-hmm. So that's great, and we do that for a couple of years, and then we collect a lot of historic data on how many cars are passing on the road every day, and then using all of that historic data. In combination with the weather forecasts, you can then make better predictions on, how many cars are going to pass this road tomorrow between 8 and 9 in the morning, for example. Which is then, a combination of the historic data from the number of cars passing, but also the weather forecast, and there could even be, events coming up, like if there's a big concert nearby, then we should expect additional traffic and so on and so forth. So combining multiple data sources is a great idea, but again, have this thing in mind around the complexity of the models, because when you add additional data sources, the models become, infinitely more complex, actually. Especially also the other case that I mentioned around, taking images from inside a house and combining them with attributes or house attributes like the year it was built and so on, and the address, and then combining that into an even more accurate and better price is also a really complex product or a complex model. So typically we are seeing that these kinds of models are being developed as a sort of a cornerstone of the company strategy going forward, because they can be so big and require a lot of time. And as I mentioned before, there's a high risk of failure for them as well.
Mm-hmm. Thank you.
Yeah. Thank you, Hans Bent. Do we have some questions from the audience? So If not, I will have, I guess, one more question from my side, and maybe it will be the last one. So if not, no more question from the audience, then my question is about like challenges. What are the, you mentioned lack of data, but what are the prime challenges you aware of that companies face while trying to bring IE into product management? So either just lack of data or something can go wrong as well. And
yeah, it's a good question. I think as I mentioned before, it is a high risk area, and there's a high chance that the projects will fail. So working in an agile fashion, I think, is a good way of minimizing some of this risk. And I see a lot of companies are not doing that in the same way. But I think generally the challenge is typically in two areas. One area being the data and the data ingestion and the data cleansing and transformation that it needs to go through in order to train the models. So that's one area, and then the other area is the business value. So a lot of companies out there are forgetting how what it takes to create business value, right? So it might be a good idea on paper, but actually bringing it into the business, actually generating value of it, and even measuring that value can be quite challenging actually. So I think in those two sort of areas, there's that's where the most companies have challenges today. It's around the data transformation journey, and then how to create business value from that specific system, right? So if we look at a simple case like customer churn, right? So now I have a file of all my customers, right? And then based on that, those customer data, I can create a model that can predict when this customer is going to leave me, right? And a lot of companies can probably do that, but it comes also to the point of saying, what should I then use that data for? Right now, I know that the company or a customer is probably leaving me tomorrow. What should I do about it? Right? That's where the business value comes in, is to extract the value from these predictions, or doing something with these predictions that means something in the company, right? It might be that you want to reach out to them, contact them, and say, hey, I have this great offering. Do you want to, or maybe call them and say, I can see you're leaving. Maybe you want to stay a little bit more, and something. Or it can be that you say that, well, if these companies or these customers are probably going to leave you, then I shouldn't do anything with them, right? Then it's just I forget everything about them. So it's all about how you use this knowledge that you gain in the company. That means something, right? And that's where the challenge is today.
Okay, yeah. And to kind of to explain to the customers how their data can be used and why it should be collected.
Yes, exactly. Yes. Yeah, and there's some it's a longer talk.
One more question, if I may. You talked about the retraining of the models. So I can imagine in quite a number of application areas, the time factor plays a role. When we look at your example with the house prices change over time.
Yes.
So how do you take that into account in your model? I mean, that the latest data that is input to the system is more relevant than data that is 10 years old.
Yes, correct. And what you typically do is that if we take the example of the house prices, which I think is an excellent one, also because because it's a relatively on paper at least a simple case, right? And if you look at it from a model's perspective, then it's basically that if a house, let's say that you take these parameters, these attributes of the house, year it was, when it was built, the address and the area that is in, and whether it has a garden, and all of these attributes, and you also have the price, right? And every time there is a house which is either bought or sold in an area, you then have a new piece of data that skews or affects the model a little bit, right? So in theory, then every time there's a new piece of data, you could potentially retrain the model, and then the model will be better at responding to that particular case. However, typically what is done is that you do the retraining when it makes the most sense, and that might be, for some models it might be every day, for other models it might be every week, for some it might be every year. So it's a little bit different from model to model on when you want to retrain it. But you typically have to measure the drift, as we call it. So you can measure how a piece of data is drifting over time, and you can also measure how much a model is drifting, or the concept of a model is drifting over time. And those two things typically needs to be sort of within a certain boundary level, within certain boundary levels. Otherwise, you sort of the model is too far off, right? It's not capturing what it's supposed to do. And sometimes it's not an automated process either, right? Sometimes you need to have hands-on, people that know something about this sit down and then revisit the code and the model, and maybe do some manual stuff around it. It's not always just an automated process. Because sometimes, imagine that you have these house prices, and then something like, you have a big financial crash, or as what happened with Corona and the airplane prices, right? So all of the AI models that were sitting and calculating prices for airline tickets before Corona, they had to fundamentally change when, after Corona happened, right? Really fundamentally. And it's not just, predicting the ticket prices and offering them for sale, but it's also like, maybe we should alter the entire concept of selling airplane tickets, right? So that's a good example of a place where models are changing so fundamentally that you have to basically revisit everything you've done.
Thank you.
Yeah.
So, any more questions from the audience? If not, then I think it's time for us to finish this great webinar, seminar. So stay in touch with us. So if you have any question, please send us feedback, or if you want, you can reach Rasmus on LinkedIn. And looking forward to be in touch with you, Rasmus, as well. And so then to all of you, and this event is over.
Thank you.
Thank you very much.